Determinant is a number characterizing a certain matrix and computed from the elements of a square matrix. If you have, for example, matrix 3 by 4, you can't calculate determinant for this matrix. But as you have a square matrix, you can calculate determinant for it. The determinant of a matrix A is denoted in this few ways. If our matrix written in round or square bracket like this or this, we know that this is matrix. But if written like this, we know that this is determinant. Why do we need to calculate determinant of a certain matrix? Well, there are a lot of usage, for example to solve system of linear equations. Or to find the areas and the volume of different geometry shapes. We defined that determinant is characterizing a certain matrix, but how exactly determinant characterizing it? Let's consider few examples. First example. We have a matrix 2 by 2. Its determinant equal 1 multiplied by 1, minus 1 multiplied by, minus 1. I will describe this technique later in this video. In this example determinant equal 2, which is a positive number different from 0. Second example, matrix also 2 by 2, but in this time determinant is 0. Let's draw geometric interpretation of these two examples by using vectors. If the matrix elements are real numbers, the matrix can be used to represent two linear maps, one that maps the standard basis vectors to the rows of matrix, and one that maps them to the columns of matrix. If you don't remember, in mathematics, the standard basis, also called natural basis, for a Euclidean space is the set of unit vectors pointing in the direction of the axis of a Cartesian coordinate system, for example, and the standard basis for three-dimensional space is formed by vectors j, I and k like on example. Now we can return to our first example and draw two vectors in two-dimensional space, because we have 2 by 2 matrix. 1 and 1 denote vector in first row. 1 and minus 1 denotes vector in the second row. As you can see we have an angle between these two vectors, which is 90. Now we can draw second example. First vector denoted by 1 and minus 3. Second vector denoted by 2 and minus 6. As we can see that are lying on the one line. So if all vectors form a basis, determinant will be not 0. And vice versa, if at least two vectors lying on the one line, determinant will be 0. Determinant of matrix 2 by 2 denotes square of parallelogram, which built by vectors from matrix rows. This square will be not 0 in case if all vectors not lying on one line. Same works for larger size matrix. For example matrix 3 by 3, geometric meaning of determinant of such matrix denotes parallelepiped volume. Thus, the determinant shows whether the matrix vector forms a basis or not. If the determinant is 0, they do not form a basis. How do we calculate the determinant? For matrix 2 by 2 we will use the Leibniz formula, which looks like this. So we need to multiply A by D, and subtract from this product the product B on C. Consider example 2 by 5 minus 3 by 4. This is equal to minus 2. One more example. For 3 by 3 matrix we have few ways to find determinant. Let's consider few of them. First we will look on triangular rule. For this we need to draw our determinant twice. Then we need to do next. Connect elements of main diagonal. Unite 3 points that form an isosceles triangle, whose base is parallel to the main diagonal. Draw one more isosceles triangle, whose base is parallel to the main diagonal. For second part we need to connect element on the antidiagonal. Sometimes it is called counter-diagonal, secondary diagonal. Write first isosceles triangle, whose base is parallel to the antidiagonal. Write second isosceles triangle, whose base is parallel to the antidiagonal. Multiply connected elements and write them with plus sign. For the second part also multiply connected elements, but take them with minus sign. Now you understand why this approach named as triangular rule. Now time to consider some abstract example. We have matrix 3 by 3, with elements from a 1 1 to a 3 3. First step, multiply elements on main diagonal, a 1 1 by a 2 2 by a 3 3. Next, multiply elements on first triangle, a 1 2 by a 2 3 by a 3 1. Next, multiply elements on second triangle, a 1 3 by a 2 1 by a 3 2. As you can see, all of them with plus sign. Multiply elements on first triangle, a 1 1 by a 2 3 by a 3 2 and write them with minus. Multiply elements on second triangle. Next we need to multiply elements on anti-diagonal, a 1 3 by a 2 2 by a 3 1, and write it also with minus. Real example. Multiply elements on main diagonal, 1 by 5 by 9. Multiply elements on first triangle, 2 by 6 by 7. Multiply elements on second triangle, 3 by 4 by 8. Multiply elements on first triangle with base parallel to anti-diagonal, 1 by 6 by 8. Multiply elements on second triangle with base parallel to anti-diagonal, 2 by 4 by 9. Multiply elements on anti-diagonal, 3 by 5 by 7. The second way is a bit simpler and more universal. It is necessary to expand determinant on the first row. What does this mean? Take first element in row and write it, then strike out elements of first row and first column. Multiply first element on the rest elements. Take second element with minus sign, strike out elements of first row and second column. Multiply second element on the rest elements. Take third element with plus sign, strike out elements of first row and third column. Multiply third element on the rest elements. How to find determinant of matrix 2 by 2 you already know. You can back to the beginning of the video to remember. Now we calculate the result. It is 0. Same result as in previous way with triangles. How to calculate determinant of 4 by 4 matrix and larger we will discover on our next video.